Now that we've discussed how to solve systems of equations by graphical, and we understand that the solution to a system is the intersection point that we can visually see on a graph, we have to remember that graphing, again, needs so much precision that it's often just an estimate for what our solution is. More often than not, we rely on one of two algebraic methods for solving the system. The first of those algebraic methods is solving by substitution. The process for solving by substitution requires first isolating one of the variables in one of the two equations. And once we've done that, we can then substitute the expression that is equal to the isolated variable into the variable for the other equation, and this leaves us with a one variable equation that we can then solve. Once we've solved for the remaining variable, we can use it to substitute into one of the other two equations in order to find the solution to the system. And again, our solution is an ordered pair, so we need to make sure that we write the solution as such. So when we look at our first example, we see that the x variable is already isolated. So since x is isolated, and again, we're looking for where the equations equal each other, if x on one line equals 2y minus 5, then x on the other line also equals 2y minus 5. So we can go ahead and substitute 2y minus 5 into our other equation for x. From here we simplify. And we have the value for one coordinate of our ordered pair. We know that y has to equal 1/2. And once we know what y equals, we can go back to either equation and make sure and find what x equals by substituting in for y. So we can solve for x equals 2 times 1/2 minus 5. So we get our solution of -4 1/2. And then what we can do is go ahead and take our solution and plug it back into the other equation that was not used for finding x, and make sure that our solution matches. Since we get a true statement, we know that our solution is valid. Again, we can substitute for either of the variables. We just need to make sure that one of them is isolated. Here, y is already isolated, so we can substitute 4x plus 7 in for y into the second equation. We'll simplify our equation. And then we can go ahead and substitute x back in to our equation up here. So we get our solution, -1/2, 5. And just to make sure that it works, we can go ahead and substitute into the second equation and make sure that we have a true statement for both. And we do, so we know that our solution is accurate. Now here we've got some fractions. So in order to isolate, what it might be easier is to go ahead and get rid of those fractions by multiplying by a least common denominator for each of the equations individually. We can multiply our first equation by 6, giving us -x plus 3y equals 3. And then the second equation we can multiply by 12, giving us 4x minus 2y equals -9. Well, now that we have our equations without fractions, we can go ahead and isolate one of the variables. Now, none of them are isolated as of now, but looks like -x will be the easiest to get by itself, because if the coefficient of one of the variables is either 1 or -1, then that's going to make our life a little bit easier as we want to get ready for substitution. So let's take negative x plus 3y and get x by itself. Now that x is isolated, we can go ahead and substitute in for the second equation. And now that we've found y, let's go ahead and plug it back into one of the earlier equations. Let's continue to use this first one here. And now we have our ordered pair solution, negative 21/10, negative 3/10. Again, if we want to check, make sure it works, we could go ahead and substitute it back into the second equation. And I'm not going to spend the time to do that here, but I do encourage you to try it on your own. So same thing again, we'll go ahead and multiply by least common denominator for both equations to rewrite them. So here we want to multiply by 12. And here we can multiply by 4. And it looks like this x will be the easiest one to isolate, so let's go ahead and do that. And now we can go ahead and substitute into the other equation. So we'll substitute in for x here.